Let's now take a look at some common angles that are going to be present when it comes to figuring out the trig functions. So the positive x-axis is essentially going to be uh, when you look at the uh, terminal side, there's no real angle there, so that's 0 degrees or 0 radians. However, realize that if you were to go the whole way around and come back to the start, you're also looking at 360 degrees or 2 pi radians. So that positive x-axis can take on two different identities there, and really an infinite number of identities. When we go up 90 degrees, if I were to have a terminal angle along, or a terminal side along this side, my angle here would of course be 90 degrees, um, or in terms of pi, not a full uh, circle, it would be about a fourth of a circle. So 1/4 of 2 pi is pi over 2. So this positive y-axis is either pi over 2 or 90 degrees. Now we look at our negative x-axis. Now we've got essentially a straight line. That's going to be pi radians. It's a half a circle. And then if we go from here to the negative y-axis, we have 3 pi over 2. That's 3/4 of a circle. This would also be known as, and I should write 270 degrees, 180 degrees, and 90 degrees. And then, of course, we get back to 2 pi. So those are very important to recognize. And we're going to look at some trig functions based on those 4 terminal points on the axes. All right, this first example is asking us to look at cosine of pi. Now, if you remember, pi is over here. If we start at the positive x-axis, we've got pi, or 180 degrees, on this side. So finding the exact value of cosine, remember, cosine of an angle is the adjacent over the hypotenuse, or x over r. Now, if we were to try to draw a right triangle along this, notice that the hypotenuse of my quote unquote right triangle is always going to be the same as the adjacent side. Only the hypotenuse is going to be a positive number, but my x value on the left is going to be negative. So essentially, I have negative whatever you want to choose over that same value. So a convenient point to choose here would be -1, 0. So my cosine of theta is -1 over 1, which would be -1. Now let's look at finding the value of tangent of 450 degrees. Notice now we're going to have to think of what that would be in terms of pi. So remember, 450 degrees, if we're going to convert that into pi, is going to be pi radians over 180 degrees. So essentially 450 pi over 180. That becomes 45 pi over 18. Divide the top and the bottom by 3. We get 15 pi over 6. And then we can divide that by 3 again and get 5 pi over 2. So essentially, we know 1 pi over 2 is right here. 3 pi over 2 comes back down to here. So essentially you've got 1 pi over 2, 2 pi over 2, 3 pi over 2, back to the start for 4 pi over 2. 5 pi over 2 would be another coterminal angle of pi over 2. So we're trying to find the tangent of this terminal side right here, the tangent of 5 pi over 2 essentially. And tangent is opposite over adjacent. So it would be our y over our x. Now, if we're looking at our y value, it could be anything. But notice our x value has to be 0 if I'm putting a point along this line somewhere. So therefore, we're getting some value y over 0. That means that the tangent of 5 pi over 2 is undefined. Now let's look at finding the cotangent of 7 pi over 2. If we count by pi over 2's, this will be our first pi over 2, and then our 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 ends up being somewhere down here. So now, remember, tangent was y over x, so cotangent of theta equals x over y. So now, realize, again, x has to lie on this line here. So x is always going to be 0 no matter what we choose to put as our y value. So in this case, cotangent of 7 pi over 2 is technically equal to 0. So now it's your turn. See if you can figure out the exact value of the secant of 3 pi over 2.